recorded so many times over again because I had no volume. Okay, I can solve and graph solutions. And when you see that, is there any question that you think of? Bryn?
What's the solution?
Perfect question. What is a solution? So glad you came today to find out. A solution is an ordered pair that makes an equation true. Lucy had a silly question first hour. She said, what about pear like the fruit that you eat? This pair, like another word for two people or a duo or two things that go together. What two things go together? Bryn?
Oh, I have a different question. But
X and Y go together. Bryn?
pair mean connect? Like P-A-I-R, like connect? Like if you're connecting to a Bluetooth?
Oh yeah, so that would mean two things that are going together. Like your iPods and your phone.
Oh.
Or whatever it is. They go together. That's a good example. So in graphing, the two things that always go together are the X and the Y. Kind of like at the end of the alphabet, X, Y, Z, just without the Z. Is that making sense? And also, there was several lessons in the last chapter where this happened. The variable hops out and the number hops in. There's a fancy name for that substitution. So right here, this one's telling me when X hops out, a -1 is going to go there. So I know the first number in my pair is -1. Questions about that? Okay, so then I have to figure out how to get my Y, the other number in my pair. Does anybody see? Is there any other spot X could go? Allison? 3. Oh, look at right next to the 3 is a spot we could put another X. Maddie?
It's smushed together, so that means it's multiplication.
Yes. Smushed together means multiply. Three times -1. -3 plus 4 feet. Oh, you're close. Normal one. So now we just found the other part of our pair, or our buddy. What's the pair with -1? 1. Out hops Y. In hops 1. Now we know the X and the Y that go together. They're buddies, they're partners, they're duos. Anything alarming jumping out at you so far? Okay, so let's look at the next one. Y equals 2x plus 1. My ultimate goal is to find the two numbers in the pair, the X and the Y. Do we see either of those right now? Preston.
In the final solution, it said x equals -3.
Oh, look at that. I know this number now is -3. Out hops x, in hops -3. Bryn.
You just put a 1 in front of the y since y doesn't say anything. Does that work?
There is a 1 there. This would be a time that we don't need the 1. What else could I do with my x?
Oh.
Though, Bryn.
2 times -3.
Look at that. X is filling in 2 spots. It's filling in my pair down here, and it's filling in my equation. So now I see some people doing this. I'm about to find our number for that, the buddy. Leighton, 2 times -3.
-6.
Thank you. Savannah, -6 plus 1. Thank you both. Guess what? We just found the pair. We found the buddy. Anyone want to ask for help? Oh boy, I see some people on the second box already. They must have learned something. Bryn?
You can replace, or you can do -4 times -3.
Oh, look at that! X is hopping out again. -3 is hopping in. Bryn, -4 times -3.
Okay.
So when they're both negative and you multiply, you get a positive.
I put in -4.
Preston, 12 plus 3.
15.
Look at that. We just found a buddy. When you were in elementary school, did you have like a ketchup and a mustard buddy? My kindergartner. I can't remember if he's the ketchup or the mustard. But they work in pairs a lot, and his buddy is a girl named Brooke. So when the teacher says, find your ketchup, find your mustard, then he knows he has to work with Brooke.
Oh, it's like those shirts that we get from Justice, and it'd be like, that's my best friend. And another shirt would be like, that's my best friend.
Oh, yeah.
Like,
So we found some buddies. The ketchup found its mustard. Did anybody go over here and take out the X? Ellie, 0 times -3.
0, and then plus -4 plus 3, and then minus negative.
Both are the same thing. Are we kind of getting the hang of it? Bryn?
I have a question for the next part.
Ooh, perfect.
How do you graph that?
Oh, such an excellent question. So now, it's really tempting to just write an answer of y equals -4, but that's not graphable. So you always want to make sure x and y are next to each other, that they have their buddy nearby. Because, like Bryn said, it looks like we're going to have to graph it in part 2. So always make sure x and y have a buddy next to each other. Bless you. Okay, part 2 is this really fancy word, linear equation. And do you see anything hiding Any base word, Sophie?
Line.
Line! Linear! Really fancy word for line. So when we go to graph these points, they should make a line. There's other graphs, like you could have a U graph, or you could have a V graph. Stay tuned for 8th grade. But we really just want a line graph, line. Also, it's kind of nice that the word line hides in there, so if you forget the fancy word linear, you think, oh yeah, line. I need a line. Did you get it? Okay, so they are giving us y equals 2x plus 1. Do you see that?
Yes.
Okay, you maybe want to write down here. You have more space down here. I just don't have a lot of space down there. So I'm going to write on the side. Turns out, do you see any spot where it says x equals? No, so that's a little confusing. But it's a little bit better almost because we are going to get to pick. Be careful when you pick, however, because we're going to put it on a graph. And if Drake picks 100, that's not going to fit. So Drake, give me something that's more reasonable than 100. A number.
-3.
Say it again.
-3.
Okay. And we're actually going to do this 3 times. So Weston, will you pick me another x?
-4.
Zach, will you pick me another one that's positive?
5.
So we are now going to do this 3 times because none of these x's have a buddy yet. So we need to find the y buddies that go with all these x's. Britt.
Well, are you talking about like doing it 3 times on one graph or for these 3 problems?
On one graph. Good question.
Oh.
Also, you maybe would want to consider an XY chart to keep track of your information. And here's what I mean by an XY chart. Where Drake picked -3, and Weston picked -4, and Zach picked 5. So then the buddies can go right next door. How are we going to find the buddies again? Maddie?
We gotta figure out the lines.
How are we going to find out why?
Solve it.
How are we going to solve it? Everything you said is true. Drake,
With the x,
what about it?
you have to use that to times by the number divided by x.
Oh, okay. So out jumps x, in bumps -3. When 2 is smushed with -3, that means times. 2 times -3 is -6 plus 1. We found a buddy. Okay, now we're going to do it again. This was Bryn's question. 3 times on the same graph. Weston said -4. 2 times -4. Maddie, -8 plus 1. We have another buddy. Like Bryn said, 3 times on the same graph. Zach gave us 5. 2 times 5 is 10 plus 1. Another buddy. Yay! Every ketchup has a mustard. Every salt has a pepper. Every X has a Y. Okay, we are finally ready. Woo! This graphing thing takes some work. We're finally ready to graph. Do you remember where to start? Isabel, you remember?
So one of them is a negative square and one is like a positive, like numbers.
Yeah, which way?
The one on the left is the negative and the one on the right is the positive.
Okay, so she's saying negatives left, positives right. Wait, I've seen this before. Negatives left, positives right. Seems like the same thing. Which one is this X though?
Left.
This one?
Mhm.
So where's the Y? Allison?
Would it be on the right side?
Both of these are X actually. Isabel?
The one in the middle is that Y.
So what if Y is negative?
Then it'll be on the left side.
What if Y is negative? Ellie?
It's on the bottom.
Oh, go down if Y is negative, or up if Y is positive. Okay, let's find our first pair. Starting in the middle, but don't put a dot there, just kind of rest your pencil. X is -3. Here's my choices, right or left?
Left.
Count the boxes, 1, 2, 3, no dot. Because I need the buddy, which goes for negative.
Down. Oh, it's down.
Down 5. 1, 2, 3, 4, 5. After 3 times, we're hoping we have a linear equation, linear line. Back to the middle. X is -4. Left. 1, 2, 3, 4. Y is -7.
Down. 2 down.
4, 5, 6, 7. Ooh, that looks like a line so far. Next one. Back to the middle.
Over 5.
What's over me?
Right.
Ooh, right this time because it's positive.
Mm-hmm.
1, 2, 3, 4, 5. Up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, kind of like one box above the graph. That's okay. Now, do you have a straight edge of any kind in your backpack?
No.
I have a straight edge of my phone.
Perfect, Pete. He's holding up what I was going to hold up. These are actually my favorite straight edges because they're not too big and they don't usually break in your backpack.
I have one of those that broke in my backpack. I don't have mine with me.
Perfect, Ellie. It's okay. You just need the straight edge part. She has a little crack on the circle part. That's okay. If you don't have one of these, do you have your school planner thingy?
Oh. I'll get it.
Because the edge of that makes a really nice straight line.
Wait.
So now we're hoping that when you lay down your flat, straight edge, whatever you have, we'll make it work, that they actually line up. So look at your paper. Zach, anything straight in your backpack that you could use?
A folder.
Weston's using a science book over here. That's fine. That's called resourcefulness, Weston. We need that. Now this would be a problem. If I went to lay down my ruler and I have a dot over here and 2 dots over here. Do you see how that's not going to line up? That means I have a mistake somewhere, which is not necessarily bad, but I would have to try and fix something. So that's when Ethan told me last class, so if it makes a straight line, we did it right. Pretty much. If it makes a straight line, we did it right. Also, lines, can you think of what a line would be? Like never ending in both directions, right? So some people are tempted just to draw like a little segment, but these lines go, I'm gonna fake this and you're gonna realize why a straight line is a good idea. It's really hard. See how it didn't turn out very straight? It's really hard to try and do that without a straight edge of some sort, anything. Oh, look at this resourcefulness over here. That's a great idea. But make it go through the whole thing. Did we do it? The first one's always a little tricky because literally in your 8-year math career, if you include kindergarten, this is the first time you've done something like this. Maddie.
Do like certain numbers have to be like separate in order for you to get like a straight line, or can you just pick whatever numbers you want?
Oh, like if Weston picked -4 and I went, ooh, you do not have to pick -4. You can pick any x's that you want within reason because you need them to fit. 100 just wasn't gonna fit. But usually like small-ish, between like 5 and -5 somewhere. Usually most of those fit. Ready for the second one?
Are we using the same X's?
Was that a yay?
Yay!
I knew it. Ellie, good question. She said, should I use the same X's? Totally up to you. If you want to, of course you can. If you'd rather use something else, of course you can. But we do want it to fit. Savannah, what's something you're thinking over there?
I don't really know. What? -6?
Normally that would be okay. I just don't think it's, here's what I'm predicting it as. 3 times -6 is going to be -18. So that might not fit. What's your second choice?
-4.
Okay, we'll try it. Preston, what are you feeling like?
-1.
Well, when did you?
Bryn, what are you feeling like?
2.
If you are someone who thinks, why are these people picking negatives? I hate negatives. Don't pick them. If you think, oh, I always get my negatives wrong, don't pick them. Maybe pick 1, 2, 3 then. You're kind of the boss of yourself at this moment. What X's do you want to pick? pausing because people are thinking, which is good.
Oh,
And remember, the moral of this story is make a line. Maddie.
For the negatives, like once you get closer, are you supposed to do like smush stuff with glue?
Here,
Well, cause I did, yeah. So like for example, like in -4, I did that, and then it turned out to be -12 minus 2. So is it okay if I just did stuff like glue?
yeah, great idea. Because we have actually two negative numbers, -12 and -2 more. Bryn?
oh wait.
You're probably going to make a mistake because it's the very first day you're doing something. Then you just realize, oh, I'm going to try again. Did anybody do Preston's -1? Did you get -5? Did anybody do Bryn's 2? Did you get 4? Now, so far, all I have is, I'm hoping this makes a line. So then I put the dots on there to see, does this make a line? I am thinking that I can't make my -14 work on there. No problem, I'm just gonna try another one. Like maybe 0. Three times 0 minus 2. So now I'm hoping when I lay down that flat, straight edge, whatever you have, what I don't want is an angle, right? I do not want an angle. It wasn't an angular equation. I want a line. So I'm hoping, whoa, look at that. There's my line. Shout out now if you need some help. This is the very first day. Good job. No. Total coincidence. Ready for my third one?
Oh no.
Here's a hint I would give you for half. What numbers are easy to take half of, Annie? Both of these together. If I take half of 9, I get a decimal, and that's a little messy to graph. So Bryn says, what about even numbers? Like
4.
what else is even?
7. No.
What else is even? You can do it negative if you want.
Oh, but it's a negative.
So what's half of 4?
2.
2 with a negative. Good observation. Plus 4. Now I'm kind of repeating. What's half of 6? 3 with a negative.
-1.
Plus
Positive. Or positive.
half of 2
1.
with a negative. Plus 4.
Positive.
I didn't pick any x's any negative x's this time. That's okay. Over 4, up 2. Over 6, up 1. Over 2, up 3. Oh, this one went a different direction. Did you see that? The first two were kind of going up. And this one was a little bit, what's a good word for it? Flatter, not as steep, and it went down. That was weird. Maddie.
Probably because you're doing this.
What? Did you hear that? She said probably because of this negative in here. That's such a good observation, Maddie. Whew. We're definitely going to think about that some more. Any other questions, concerns, comments? Here's the 2 places 7th graders make mistakes. Mistake number 1, somewhere in the math part, they made a simple mistake. Mistake number 2, they accidentally counted in the wrong direction. And then they think, what? Why doesn't it line up? Oh, you went up instead of down. Something silly like that. That's okay. That's why we have eraser. Any